And okay, I think I'm ready. Hopefully I didn't forget something. Too many buttons to click. Let me just make this a little bit smaller this way. Come on, what's going on here? There we go. Okay, I think we're good. All right. Yeah, right. So let's get underway. I don't know. I feel like I got a bunch of things on my mind, and I can't remember them all. This isn't today, isn't this week. There's still snow on the ground. This is down same spot you've seen a few times with my slides. It's the closest place for me to take Dora for a walk. This is back probably the end of October, and we're walking down at um, it's along the Northwest Arm near Melville Cove, the Armdale Yacht Club area. Spot you can see from the Armdale roundabout. Quinpool Road is over on the left-hand side. What's interesting here, I find in this slide, it's one I used last term, is the boat in the background. That if you're familiar with boats that come into Halifax, we get a number that come from Europe, actually, come all the way across. I can't believe they do. But primarily they're coming from that they'll fly a French flag. And so they've come from Saint-Pierre-Miquelon, so just the islands between Nova Scotia and Newfoundland. Still quite a ways to come, and not a very nice sailing voyage from what I understand. But sometimes we will get ones that are coming from Europe. This boat is not local, definitely is not built here. And it came during the summer, and it's still there. That even today you'll see it in the Northwest Arm by itself. And you'll notice there's a little dinghy on the back. There are people that live on the boat, and that little dinghy is still there. The boat moves back and forth up and down the arm. Sometimes it anchors in other locations, but they've been living on it since the summer. And I just, ugh, it's so cold. And they can't dump their sewage into the arm, so I'm not sure what they do. But we won't get into that. But no, there are some strange sailors that we get that come to Halifax. So, and since we're getting into building models to predict things, and we're looking at correlation a lot between variables, what things go together, that in the text for material in chapter 7, that it's chapter 7 we're starting in on. I think I give the link to the website that this fellow has created. He's taken time series data. So this is taking some variable you take snapshots of over time. And he's found pairs of variables that have the same trend. So one of them was from 1999 to 2009, the number of Japanese cars sold in the US, how it went up and down, the red line, and the number of suicides caused by people ramming their cars into walls or trees or telephone poles or something like that. And they look the same. So if we want to cut down the number of suicides, it's been fluctuating between about 90 to 100 and 140 or thereabouts, that maybe we just restrict the number of Japanese cars that can be sold in the US. No, wouldn't work that way. But it highlights how patterns, particularly what we see over time, and this is a very common fallacy people run into, that if they see a trend in one variable and the same trend in another variable, they think they're linked in some fashion. A long time ago, I used to use data about handgun sales in the US and the number of homicides. And as the number of handgun sales went up, the number of homicides, number of murders increased. But, and this type of data was used. I'm not a gun advocate at all. I hate guns. But this type of data was used by those that wanted to control firearm sales to say, look, that as more guns are sold, that we get more murders, that maybe we should stop selling guns. And the response from the gun owners was, no, the guns are bought in response to increasing murder rates. The data was from Detroit, which at the time had a very, very high murder rate. And so as the number of murders go up, people get scared and they go out and buy guns. So the purchase of guns is a response to fear of the increasing murder rate. So they also had data that was the number of police officers and the number of murders. As we added police, or they added police in Detroit, the number of murders went up. They said, no. It wasn't because of police causing additional murders. It was as murders went up, the public screamed and wanted more police. And so more money was put into hiring police. So they were related ones, maybe. But what was happening was we couldn't say which one caused the other, which one came first. And this morning I was reading an article about why we talk of particularly men with large bellies as having a beer belly. The more beer you drink, the larger your belly becomes, the more weight you put on. And studies have found that there is no correlation between beer consumption directly and what's in the beer and weight gain. Yes, there are additional calories, but if you drank more orange juice, the same way there's lots of calories in orange juice or other beverages. The problem isn't the beer, it's what you eat with it. If you're having a bunch of guys over to watch a hockey game and they're all drinking beer, the snacks they're eating are not celery sticks. They're not eating lots of salad. They're eating very high calorie snack foods. And it's the snack foods, particularly high fat ones, that are the reason for the weight gain. It's so the beer is an indirect thing. It's the foods we eat when drinking beer that are the main culprit in the weight gain. So just highlighting, looking at patterns that we see, and we'll be seeing that today, aren't always what they appear to be. And we'll see that happen with the data we're going to use today. So regression analysis, it's a technique, very, very common technique, the most popular one for doing value estimation, at least as a formal technique for doing it. Many of you have contributed to the discussion on, well, do we have to use a formula to do value estimation? Can we do other ways? And I suggest appraisals of homes or damages and that sort of thing. And there are a lot of very good comments. There's huge amounts of knowledge we can't put into a formula, or it would be very difficult to do. And so there is a real role for other knowledge, that tacit knowledge that doesn't fit easily into structured things, that give us opportunities for improving forecasts. And you'll see that in your next assignment, because it's going to use housing data, local housing data from Halifax that I'm trying to put together at the moment, that about house sales in the last year, because it's been a very interesting housing market this year. But you're going to find you can't make very good predictions. But real estate agents seem to be able to make much better predictions when they set the asking price for a home. So they must use special knowledge that isn't easily quantifiable. But we're going to look at regression because it's the most common formal technique, and there's a lot we can learn from it, even in the process that's used for building the models. And with a formal model, one of the nice things sometimes it isn't always that, is that we can do causal analysis and we can isolate different factors and say, what's the impact of this factor on this outcome? Not always can we do it because they're interrelated, like beer drinking and eating potato chips. Okay? That you can't separate out the impact of the beer from the potato chips because they seem to go together. But um, causal analysis can be really valuable to us in trying to explain what's happening. The variables that we use, we tend to describe the input ones, the ones we're using to make the predictions, as independent variables or explanatory variables. Now, they may or may not be able to explain what's happening, at least in a fashion we can understand. But that's a general term you'll often see to describe those variables. The outcomes, on the other hand, are often called dependent variables. They depend upon the inputs, or they're the target variable. They're what we're trying to predict. Target variable is often a term used in data mining. Dependent is often used in statistics. So they're different words people use. You should be familiar with some of the language that's being used around this. The method we use, again, the most common approach is least squares. You don't need to know the math, but you should be aware that it's a technique that we're trying to make good predictions. Good meaning we don't want an error in our, well, a large error in our prediction. And in fact, we're going to assign a bigger penalty, a far bigger penalty to large errors than to small ones, because we're really afraid of making big mistakes. But little mistakes happen all the time and we deal with them. Okay, so having a square in there adds that extra penalty in there. There are other approaches besides least squares, but this is the most common one. And the other thing is that we're going to be focusing on linear models, on straight lines. It's in part to keep it simple, and it's simple not just in mathematics, but it's easier to explain. It's easier to build. It's easier to work with. You're using simple, basic tools. You're not adding unnecessary complexity. But there are instances where we build nonlinear models or we transform variables so that they're um, nonlinear because there's good reason to do so. But as a starting point, and we're just covering the basics of this course, we start with linear. We also have performance issues, and I'm not going to get into that now, but we'll see that as we build some models today. But there are two measures of performance. One is how bad is my prediction? How far off am I going to be? How big are the errors? How big are the mistakes? Am I off by $100 or $500 or $1,000? So in concrete terms. And then there are other measures that are sort of summary, generic performance measures. And it's like getting an overall grade. And R-square is the most common method of giving you a grade to how good your model is. So when building it, I'm going to introduce this topic and then I'm going to leave it and I'm going to come back to it later. But you got to think about how do you improve? Last time we built a very simple model that took the customer's credit rating and predicted their credit card balance. And it had a B level performance, an R-square of 75%, but the errors were pretty big. Typically in the area of $200, $300 off was common. And that wasn't good enough. So we'd like to improve. How do you go about improving performance? And that doing it, we should have a process for it. And I don't think people think enough about process. And so one of the takeaways I want you to get from the course is to think about the process. How are you going to build the model? How are you going to improve it? And if you want to improve performance, I'm going to say that learn from your mistakes. Look at where you went wrong. See why you went wrong. and see how you can do better. And that's why we're going to look at the mistakes we made. We call that residual analysis, or we're going to look at residual plots. What are those? And I'll show you how we get these. When we fit our initial model, here was the scatter that we had, the blue dots. We put the orange line through it as our best guess. And as you can clearly see, lots of points are above the line, lots of points are below the line, almost no points are sitting on the line. There's some close. Okay? And that's common. You don't make perfect predictions, that you're going to be some error in it. But if you're looking at how big the mistakes are and where the mistakes are and what you can learn from them, that graph is actually difficult to use because of the way we process information, or at least some of us do. With this one, if I'm looking at how broad is the scatter around that line, what do I look at? I tend to look perpendicular to the line. I look at how wide the scatter is. The line's going sloping up to the right, so I'll look at the scatter looking in the opposite fashion, down to the right. But that's wrong, because if someone had a credit score of, what's this, 600, 500 here, I think it is. Here's my best guess. But the errors I'm making, some are above that line and some are below. The errors are vertical, and that's actually quite a big gap. And but I tend to look diagonally when I'm trying to measure scatter. It's just a natural thing. And I'd like to look and see, well, are the errors I'm making in the middle similar to the errors I'm making at the bottom or at the top? And it's a little bit hard to judge that from this picture. Let me turn it and look at I don't care what the balance is, right? I'm looking at how the mistakes change as I change the rating. So let me graph the rating, and I'll graph the mistakes, how far above the line I am or below the line. And you'll see that in the middle, that's where I'm making most of my mistakes. It's right in here. There's a lot of scatter taking place. I don't have a lot of values out here, but I'm not making a lot of mistakes out at the end. And even down at the bottom end here, I'm not making lots of mistakes. They're different. And the other thing is, I don't know how much attention you gave to this bunch here. These are customers that have a credit card balance of 0, nothing owing on their card. Okay, they were just sitting down here at the bottom. Now, that's this line that's sloping down here. These are the ones with a credit card balance of 0. So I've just twisted it. So I'm just turning the graph around. But now it really stands out. And I'm like, I got a big hole down here. Why don't I have any scatter below? Because I'm not allowing customers to have a credit card balance that's below 0. And most customers wouldn't anyway. You're going to pay off, if you owe $150 on your credit card, you're going to pay off $150. You're not going to give the bank $200 and give yourself a negative balance. You'll just stop at that point. So this is an odd feature, and maybe we should be using that odd feature. Maybe we should be taking into account customers that have a balance of 0. Do that in some fashion. So there's more information here than we thought, but we're going to revisit this later. Okay? That, as I said, changing the picture helps us understand what's happening there. And what we're going to be doing is trying to focus our attention on our mistakes. And that's what this line, this picture, emphasizes. Here are all the mistakes we made. Okay? It just how big the mistakes were and what can we learn from the mistakes. But we'll get to that. Let me go back. We had a model previously that was a relatively simple one. We said that balance is equal to some numbers times your credit rating. And then we predicted from that. And we built that very simple straight line model because rating had the highest straight line correlation between it and the balance. And that was why we fit that line, that thing I just had a second ago. This pattern seemed to be the best. So what about getting better? Generally, the first thought people have on how to improve, they don't think about their mistakes. They just think about, well, I need more information then. So let's put more information in. If I use more information about my customer, then I'm going to make better predictions. And well, what information should you use? Well, stuff that you think is relevant, that tells me a lot about my customers. So let me look back. And this is what we had last time. We had all this data, and we did these plots, and we saw, as rating went up, then balance went up. Let's use that. We also said, well, as income goes up, balance goes up, maybe we should be using it. That would be a good idea. But we looked at number of credit cards and we said, yeah, that's not really telling me anything at all. And if I looked at age, that wasn't telling me anything at all. I'm not going to use that. And if I looked at how much education you had, that was useless. But credit limit, that was good. So credit limit tells me a lot about balance. We also looked at correlations. This was the correlations we had among the variables. And the reason why we were looking at balance, why we picked rating, is it had the biggest correlation. But a very close second was limit. So if I'm going to add something to my model, I'm going to add something that seems to predict balance really well. I'm going to add limit to my model. Okay? So I'm going to fit this model here. Balance is going to have some starting point, an intercept. It's going to have the rating and some coefficient for it, and it's going to have limit and a coefficient for it. And I'm going to put all of this stuff into Excel. Okay? Let's do it in Excel. Let me go here. So I'm going to go back to my data here that I had. And what I recommend is that every time you build a new model, put it into a new sheet. Don't mess with your initial data set. We've said that before. So I'm going to use limit and rating, and I'm also going to pick balance. So I'm going to take these ones together, okay, and I'm going to put them into a new sheet. It's tiny, but you can see it all there. And I'm going to go up to data. I'm going to go to data analysis. I'm going to say regression. And I've got some stuff from previous class still sitting around here. So my Y variable, what am I predicting? That is the balance. That's in column C. So I'm going to put in, type it in, C1 up to C401. 401 because that's the last row where my data is. I have 400 observations plus the label at the top. That gives me the 401. And my X variables are together. They're in A1 to B401. Okay? I've got labels at the top. I normally like to have labels in mine. I'm going to put everything on this one sheet. Okay? I'm going to put it over in E1. We'll keep everything together. And at the moment, I'm not going to give you the residuals, but I will look at them later. We're going to come back and do this again. Okay? I'm going to click OK. Gives me a bunch of things here. Let me make them bigger so we can see it. Okay. And let me just, this is, we've got, sorry, rating, oops, class. I kept adding sheets and I forgot what sheet was which. So I have rating and I've got limit and balance. Okay, that's enough to remind me. So what have we got here? If you recall what the previous model looked like that we had before, we have 3 blocks of information. First one you look at is this one. This one gives me performance, and I only look at 2 things. One is R square. Let me make this just a tiny bit bigger so you can see. I'm not sure how this comes across on your screen, but my eyes are not great. So my R square is 0.74594, about 75%. What was it before? About 75%. It's not helping me at all. I'm no better. That how big are my mistakes? Typical mistake, $232. Yeah, it was $232 before. It's no better. It's what's happened? Well, let me look at my model. Okay, let me just put the old model first. Okay, it was estimated average balance. Remember, it's an estimate, and it's of the average balance. It's not predicting the points. It's making the line. And the old one was roughly, I think, minus 139, 300, minus 390 plus 2.57 times the rating. What's my new model looking like? Well, let me scroll down so I can see it. Here's the data that I need. Stuff that's sitting right here. Okay. It's saying, yeah. Okay. Maybe I have to make this a little bit smaller so I can get it all in. There we go. It says estimated average balance equals minus 377. So it's changed a little bit. Was 390. But if you recall that our coefficients are also estimates, and they could be wrong. How big a mistake could I be making? Not unusual in this one to be off by $45. Last class, our estimate was off by typically $29. So this is close. It's not unreasonable. Okay. So what happens next? Plus 0.02, what, 5 or something here, times limit, plus 2.20 times rating. Okay. What have I got here? The coefficient for rating is much smaller now. Well, okay. That maybe that's understood. Okay, that limit and rating, I'm not sure. This is an estimate. It says that the estimate could be off by 0.95. Ooh, so this could be way off. This could be, as high as 3 or as low as 1 almost. There's a lot of error here. So maybe it really hasn't changed that much. It's a bad estimate. Look at limit. Now, don't be obsessed with the small number, the 0.02, whereas this is 2.2. The credit limits went up to about $12,000 or $14,000, whereas ratings went up to 1,000. And so limits tended to be about 10 times or more what the ratings were. So just in terms of size of numbers, we might expect the coefficient to be smaller because limit is a really big number to work with. Now it's a lot smaller, but don't read too much into that. But look at the standard error. The standard error is 0.0638. So this is saying I could be off in my estimate of the slope by 0.06. Okay, if I was off by plus 0.06, maybe this number should be 0.08 or 0.09. But the other way, maybe I should be off by about minus 0.04, maybe even more than that. What does it mean to have a coefficient of minus 0.04? It means that the relationship is negative, that as limit goes up, balance goes down. That doesn't seem to make sense. If you're allowed to borrow more, you're probably going to borrow more. You're not going to borrow less because you can borrow more. That doesn't make sense. But it could also be going up, like the way we expect. So it could be that as you increase limit, balance goes up, yeah, or balance goes down, or balance just stays the same. We don't know what's going to happen. We really don't have a good idea of how limit affects balance. In fact, maybe limit just doesn't affect balance at all. Maybe it's just noise. Let me get back to my slides then. So, yeah. So, yeah, here I've worked it out. So, balance may increase or decrease with a higher credit limit, or maybe it doesn't change at all. There's no clear evidence that the limit influences the balance at all. Probably shouldn't have it in the model. It's not giving me new information. And why? It's because if we did a simple scatter chart of credit limit versus rating, we get a straight line. If you tell me the customer's uh, credit rating is 600. Oh, their limit is $8,000. How about a credit limit of 1,000? Or sorry, a rating of 1,000. Oh, we'll give them a limit of $14,000. You tell me the rating, I can tell you the limit. They're perfectly correlated. If you go back to that table of correlations, where was I? Correlation. Look at it. Rating and limit. Boom. 0.99688. That's as close to 1 as you're ever going to see. That the bank probably goes and says, okay, what's the customer's rating? Oh, 600. Okay, we'll let them borrow up to $8,000. But tell me what the rating is, and the bank will set the limit. That seems to be what's happening with a little bit of noise thrown in there. So limit's telling me nothing I didn't know already, and it's not helping me in building a model. So let's try something else then. they let's put income in there. And if you recall, when looking at charts, here was balance versus income. As income went up, balance went up. So how do I do that? How do I build that model? So back here again, I'm going to take income, I'm going to take rating, I'm going to take balance, I'm going to copy them. And I'm going to put them in a new chart because this is a new model I'm building. Okay? And now I can go and fit my model. That it's not just important for me to take over the variables that I want and work in this fashion and not use the original file, because there are other quirks to do with Excel that affect the way we build models here. Let me go and just show you quickly what would happen if I just said, oh, let me just grab these guys, this one, and I'll put them in my sheet. I'm just going to throw them over here for now. Okay. And if I went to build a model with this, and I go to data analysis, regression, okay, my Y variable is in column I1, I401. And my X variables are, well, it's going to start, let me just move this over here. I've got income. I want that one. I'm going to do it just the way I select things any other way. Okay. And at least on a PC, I hold down my control key and I grab rating. Okay. I've just grabbed the two variables I want. Seems simple. Makes sense. All right. And I'm going to put the output. It's going to complain. Let me put it over here in K1. It's over to the right, out of the way, and click OK. I get an error message. I know this is probably too tiny for you to see, but it says regression. Input range must be a contiguous reference. What's contiguous mean? Contiguous means they're joined together. Basically, all my variables are together. There are no gaps. I don't have to jump over anything. I don't have to jump over limit to get from income to rating. Okay? So let me just cancel this guy out. Oops, sorry. I clicked OK by mistake. Let me get out of here. Okay. If I took limit out, then it's going to work. Let me just get these guys out of here right now. So by having them side by side, it'll work. So your variables, your X variables all have to be together. Your Y variable is just one column, so that's simple. But your X, if you've got several, have all got to be side by side, or it won't work. So let's go data, data analysis, regression. So my Y variable is in column C, and my X's are from A1 up to A401. Okay, and I'm going to put my output over in E1 so I can see it. You widen this, you can see the words. And uh-oh, I did something wrong. These numbers are wrong. I mean, my model's worse. My model can never be worse than I had before. So what did I do here? I've got income, rating, balance. Go back here. I've got regression. I'm predicting columns. So you've got, oh, see, I made a typo. I went column A and column B. Okay, now we're good. Let's do this again. All right. So you remember what you had before? Previously, the R square before that we had in the previous model was 0.745 something, okay, about 75%. So now I'm at 87.5% is my R square. That's this thing here. Is that good? Well, before we were at 75%. The best we could possibly do is 100%. So we're actually halfway in between there. So this is perfect. This is where we were, and we've closed the gap by half, which is that's a big accomplishment. So we're an awful lot better than we were before. Okay, but look at standard error. It's 162. Okay, previously we were at 232. So typically we made mistakes of $232. It's just sort of a loose way of describing our errors. Now our errors are $162. Better. Perfect. Zero. No errors, right? So do you think you're halfway there now? No. We've not closed the gap by one half. So R square is better. It's a nice simple grade that we've got. But in fact, it's not halfway to our destination. It's about a third of the way. And it's there's a whole bunch of mathematical reasons about how these two things are measured. But is that I'm cautious about R square. I find it deceptive. It fools me many times, and it makes me think I'm doing better than I really am. I like to look at standard error, and I want to know, okay, I made some mistakes. How big are my mistakes? And so I'm better, definitely. Having errors of 162 is so much better than 232. But I'm not quite, this suggests here I'm an A-level performance. Before I was a B. I should be really happy. I'm not quite that happy yet. I'll get better, but I'm not there yet. Okay. So let's look at the model. Remember, we ignore this table in the middle. And what's our model? So first off, let me just write out what my model was before so that you're used to reading these things. Before, my model was estimated average balance was equal to minus 390 plus 2.57 times rating. Okay. As my rating goes up by 1 point, my balance typically goes up by $2.57. What's my model look like now? Well, it says estimated average balance is equal to minus 534. Ooh, that's quite a change. But remember, intercept most of the time is meaningless. We don't interpret it. It's a starting value. I'm trying to draw a line through a bunch of points, and the line extends all the way back to zero, even though I'm never at zero. I'm never dealing with someone that has zero income and a zero credit rating. It's just I need a starting point. Okay? I'm typically working way out here, but for the equation, I need something that goes down to zero. Don't worry about it. But look at the other numbers. Minus 7.67 times income plus 3.95 times rating. So looking at this one here that I've got, the rating information that, can I change it? There we go. It's changed a lot. That now a 1 point increase in your credit rating seems to increase the amount you borrow, not by $2.50, but by $4. It's a big change. What's going on? Well, look at this one. Look at the income variable. And let's make you purple. This one is interesting, particularly because of, if I can highlight it here, not very well, the minus sign. This minus sign here. As income goes up, your credit card balance will go down. If you have higher incomes, you will borrow less. This is troublesome. What's going on? Go back to your charts. Income, balance, income goes up, balance goes up. And look at your correlations. That as income goes up, balance goes up. Correlation plus 0.46. What's going on in this picture? Why is it going down? Well, we have another problem. Income and rating are related to each other. I've got a picture of that in our slides. So this was the one I just showed you. As income goes up, credit rating goes up. So if you were higher income, the bank's going to give you a better credit rating. That's obvious. That makes perfect sense. So if I change your income, I change your rating. So I can't say if someone's income went up by $10,000, how will their balance change? Because as soon as I change their income, their rating changes. I can't figure out the change that had to do with the income because I changed the rating, and it's the two of them combined predict balance. I can't separate the two. Anytime I change rating or income, the other one changes at the same time. And so I can't study one of them by itself because the other one moves. Every time I go to study it, the other one moves. And that um, the model's better because income is giving me new information that rating didn't. But I'm having trouble explaining what that means. What exactly is it doing? And this is a very frustrating aspect of this model. It's a better model, but whereas before I could explain why changes in one affected balance, now I can't. That the the problem, it's given a name. It's called multi-linearity. That it means when you have your x variables, your explanatory variables are interconnected. If they're interconnected, you can't change one without changing the other. So you can't separate them. They're joined. They're like Siamese twins. You that you can't talk about one without talking about the other at the same time. It doesn't mean that your model can't give you good predictions. It just means that when you do causal analysis and trying to explain why your prediction is the way it is, I can't talk about income without talking about rating. And this is a serious problem with causal analysis, that we'd like to be able to separate out these different factors. That your assignment, once I get it put together, as I'm working on just building the data set, is slow because I have to look up properties one by one by one and extract the information. I can't. There should be a way to scrape that stuff, but I'm not a computer scientist, so I don't know how to do that. But within it, you're going to get data on what the house sold for, how many square feet was the house, how many bedrooms, how many bathrooms, that how old the house is, that does it have a basement, or is it a finished basement? Does it have a garage? How big is the lot that it sits on? So a lot of different variables there. But you should realize that they're probably correlated. If you've got a bigger house, it probably has more bedrooms, might have more bathrooms. If it was a really old house, probably only has one bathroom. If it's a new house, it's probably got two or three. Um, they build houses different today than they did in the past. Most of this data is actually on houses in the west end of Halifax, and they're 70 to 120 years old. So lots of them have only one bedroom or one bathroom, maybe two. But the, the my point is that there is a relationship between like the size of the house and the number of bedrooms in the house. So if I know the size of the house, and you go and say, well, it's a 3-bedroom house, yeah, I could have guessed that given how big it is. I can guess some of those sorts of things just on other variables that I've got. So they may be adding additional information, but they still may be interconnected. Okay. So sometimes, like credit limit, it gave me no information. With income, it does give me some, but it's in a confusing way. So you have to think about these things in building it. So part of our problem here is the process we followed. I was saying, okay, I want a better model. What should I add into the pot now? What should I throw in? And income might be a good one. Age might be a good one. This one might be a good one. I just throw it into the pot. I don't have a systematic strategy behind it. You should have a strategy. And there may be many strategies, and there are different strategies for building models. This is the one that I like because I can explain the rationale. I'm starting simple, and I'm going to add things incrementally if I think it improves. How do I know it improves? I'm learning from my mistakes. I'm going to look at my mistakes, and I'm going to say, oh, this one was $400 too high. Why was that? Could I have predicted that I was going to be $400 too high? Could I predict my mistake? If you could predict your mistake, you wouldn't make it. So why don't I predict my mistakes? So I'm going to look at the mistakes I made. We call those residuals. That's a term in statistics that is generally applied for the errors in predictions in regression models. They call residuals. Residuals are what is left over. What could you not explain? So if you thought of R square as explaining variation, what variation could you not explain? And at the individual level, what's the leftovers that you couldn't deal with? Those are residuals. And if I can explain those mistakes, I can build a better model. And that's what I'm going to try to do. Okay. So first off, how do I get them? Let me go back and get you some residuals. So let me go back to this one was, let me just give it a name. I'm going to come back and do it again anyway. Let me just go back to my original data. I started my first model. I took rating. I took balance. Let me add a sheet here. I put them in. I went to data, data analysis, regression. My y variable is in column B. My x variable is in column A. Add labels. I'm going to put my output here in B1. And I want to know the residuals. So of the different boxes down here, there's a whole bunch that have to do with residuals. The two most useful, for us at least, the others can be as well, but within the scope of the course, we can't cover everything. We're going to look at the basic residuals and a picture of them, a picture that I showed you once before. And I'm going to click OK. And so this was the model I had before. So here was the residual plot. I showed you a picture of this previously. Okay. So this was that scatter I was showing earlier, where here's the bulk of it in the middle. I've got this strange line over here and some over here, but some really big ones on either side. And down here are the mistakes. Let me make this bigger so you can see it. And just to show you what's happening here. So first observation. Let's go back. Where is the first observation? Here's the first one here. The actual balance was $333. What was my prediction? 335. That's pretty good. But I was about 2 units too high. So if I take the actual minus the predicted, I get -2. Okay. So if I wanted to fix my prediction, if I subtract 2 from the prediction, I'll get the right value. What about the next one? The second one, I predicted $848. Actual balance, 903. This time I'm too low by about 50 some dollars. Okay. What do I get? Yes, $54. I was too low. So if I add 54 onto my prediction, I would have gotten the right answer. But look at the next one. I predicted 928. What happened? 580. Whoa, I was really, really, really high. Okay. Minus 348. my prediction was $348 too high. So if I subtract 348 from the 928, I'll get back to the right answer. So these are the mistakes I've made, the residuals. I'm going to take these, right? These are my mistakes. I'm going to copy them. I should, and I'm going to call this my residual number one, my first model. Okay. Can I predict these? Could I have predicted these mistakes? The -2, the +54, the -348. Well, what data do I have? Here are my variables here. Let me grab them all. Oh, don't want those ones. Okay. Now I'm just predicting mistakes. So I could copy balance over here too. Yeah, I guess we could. I'm not trying to predict balance, okay? I'm just trying to, so if I know the answer, I know what my mistake is. So it's don't read anything into looking at balance and the residual. Okay? And are these related in any fashion? So go to data analysis, go up here, correlation, okay? And I'm going to take column, I'm going to go from A1 across to column I, 401. And let me put the output over here in K1. And what do I get? So this is a correlation table. It's a relationship between the mistakes and the other variables. So is there anything that gives me an indication of what my mistake might have been? And so look at this column here. With the ID number, no, minus 0.02, that's pretty close to zero. Look at rating. Now, it's written this as a funny number. It has an E minus 16. Some of you may be familiar with this. Those that are not, let me just format it so you can see what it is. Make it a number. Oh, it says it's 0. Let me add some decimals for you. Oh, there it is. There's the 5.86 that was there previously with an E minus 16. What does E minus 16 mean? It means take the decimal point that was between 5 and the 8 before, move it to the left 16 places. So this is a really, really tiny, tiny, tiny number. Put it back to the number it was before. So when you see E minus 16, it means 0. And from a computer's perspective, it's practically 0. There is no relationship between my mistakes and ratings. So there's no information left in rating, at least, let's see, in one sense, there's no information left in rating and the mistakes. That it's not telling me anything. I've taken all the information out, and that's what it should have, because this is supposed to be the best straight line using rating to predict balance. And so I've taken the best line and I've extracted everything I could learn out of the ratings. There's nothing left for me to learn. Maybe I could learn stuff from the other variables and look at income. It says to predict the mistake, not the balance. Forget about credit card balance. The size of mistake we make just using rating is correlated with income. So if I knew income, I could predict the mistake better. If I look at some of the others, nope. Limit, nope. It's 0. And that's because limit and rating were both sort of the same. So I've taken all the information out of rating. I've got everything that was contained in income. Credit cards, a little bit. Age, maybe a little bit, minus 0.17. But the biggest piece is in income. You could have seen it if you wanted by taking residual. I know this is the wrong way around, and limit. I'm going to get a backwards picture, but can't do much about it. That this is the wrong way around, okay? So I'm trying to predict balance using income. But I don't know if you can see this, but this line is sloping downward to the right. Goes slopes downward. I know it looks like a diamond, but it's really saying that as I increase the income from that I am going, as my income increases, this goes down that way, the other way around. Okay, that so I should be able to get a better model by putting income into my model, and that's what we got. So we had no, not this one. This one. This was the one where we had income in there. It's a negative coefficient because it was a negative correlation. I should have anticipated this. I didn't know what the coefficients would be, but I knew it was going to end up being negative because of that correlation. And this model's better. But could I do better? So I'm actually going to go and let me take this out. I'm going to rewrite over this stuff if you don't mind. And go back to data. I'm going to do the data analysis. I'm going to do the regression again. Same one I did before. Okay. And my y variable is in column C. And my x variables are in A and B. And I'm going to put the output same place I had before. No, it's going to be the same output. But this time I'm going to ask for residuals. Okay. Yeah, I'm going to overwrite everything. Okay. So same stuff I had previously, but now I've got all the residuals, the mistakes I made. And those mistakes are going to tend to be smaller. And I've got residual plots. Oh, can you move down here, please? So first one, I'm going to look at, well, I'll do them in the order they're there. This is the income residual plot. And I'm generally looking for patterns here. And this one seems to be, yeah, centered sort of around 0 in terms of the errors I'm making. And as income goes up, it still tends to be around 0. I'm not seeing a real pattern to this. I've got some odd ones up here, and we'll talk about that next class, but we won't get into them today. That if I look at with rating, the picture is somewhat different from what I had before. Remember before I had a sharp line down here, a big ball in the middle, and so on. Notice the ball in the middle. Ball is now a bunch down here and a bunch up there. There's a hole in the center. There are actually two things it looks like that are going on here. And I'm going to need to figure those out. And that is going to be the focus of Monday's class is there's stuff happening here. There are patterns. So that means there's knowledge still in rating. Stuff I didn't realize before. Now I've got to figure out what is there. It's not as simple as we had previously. I can go and look now at the residuals, and I can look and see how big they are. They're smaller than they were previously. As I said, typical residual before was 232, and now it's 162, so it's smaller. But could I do better? Well, let's do what I did before again. Go, shoot. Here we go. Wish there was an easier way to copy and paste, but anyway. So I'm going to take these, I'm going to create a new sheet, and I'm doing like I did last class. I'm forgetting to rename all my sheets, so I can't remember one from another. So those were my residuals, my mistakes. I'm going to take the variables I didn't use, or that I've got here, other ones to work with. And where did I put this? There it is. Okay. And I'm going to go and see, is there a pattern here? I'm going to go to data analysis, correlation, and I'm going to take columns A to G. And I'm going to put the output over here in I1. And let me make it big enough so we can see it. So what do we get? Like we had before, correlation with rating and the residuals. I've got the E minus 16 saying, no, there's nothing there. Well, maybe there is, but there's not in a straight line fashion. Okay? Putting a straight line through that mess isn't going to help me. But there's some strange things happening. With income, I've taken all the information out of it too. So there's not much left here. Limit, same as before. There's nothing really here. Credit cards, no, there's nothing there. Age, there's still a little bit left, it looks like. Minus 0.09, that's pretty small. But still, maybe it's something I should pay attention to. So I could go and build yet another new model. And this time, I will use age in my model. Let me go and cheat. I've got income. I've got rating. I want age. I don't need education. And I need to get balance. Let me go back here and steal that one. Okay, so I've got my X variables, B, C, and D, those columns all together here. So let me go and do the data analysis. What was my previous model? How good was it? Oops, was that it? It was 0.875 was my R square, and my standard error is 162.88. Okay, so let's try to beat that. I'm going to do regression. My Y variables in column E. I might mention, you'll notice I give it the full description of where, oops, no, it isn't B, I'm talking to myself. It's column D. The full description of where, start to end. You could go and select just the whole column. Excel sometimes will scream along the way. It'll try to use all the blanks that are down below. So I don't recommend it, but you can do it. And I'm going to put my output down in G10. And here's my results. So remember, it was 0.875. I'm up to 0.876. Whoop-de-doo. I went from 162.88 to 162.38. I'm $0.5 closer than I was before. Not much improvement. But then I didn't think there was much information in age. that my model ends up staying much the way it was before. There are some changes around in it, but for the most part, age isn't helping me out. If I look at my residual plots, here's the one for age. This one's pretty nice. It's pretty even scatter across the different ages, but it does have these odd bits up above. These are odd, and we should look into those. If I look at it with rating, excuse me, move up then. With the rating, that it's still got this funny pattern I had before, and with these odd fellows up above. Something's going on here. Um, a straight line still is fine. I don't see any trends going up, going down, anything like that. But uh, something's strange here. And with income, basically what I had before seems pretty even across different incomes. I still wonder about these odd dots up above. You could look at other things that we're getting. These ones, odd dots up above, you might think of them as being like outliers. So you could, if you wanted to, go and take your residuals. How big are they? What are typical mistakes? What do they look like? And let's do a picture of them. No, I'm not going to use these charts. I'm going to use a box and whisker. Okay, and I'm I'm going to hide the fill. Oops. Come on. Shape, fill. I want no fill. Okay. Oops. Somehow I got to move this down here. Okay. So now you can see it a little bit better. So here is 0. The average mistake, that's where the X is in a box plot, is where the average is 0. That's the way it should be. That on average, my over forecast and under forecast balance each other out. But the median is negative. I make more often that I've got negative errors in forecasts. I've forecasted too high. Nice spread even either side in that regard. But look at all these points that are up here that are outliers. That those are the ones we were seeing in our chart as that sprinkling across the top up in the sky. These are odd, and we're going to deal with them next class. Because if we could get rid of them, we could do an awful lot better, because normally we're pretty good. It's these ones. These are the really bad ones. But most of the time, look at the errors that we make. It's between about minus 100 and plus 100. That's 50% of the time. It's between minus 100 and plus 100 as being my forecast error. That's not too bad. And the bad ones tend to be like being off by maybe 300 above and below. Not great, but maybe I can live with that. But these big ones, when I'm off by 600, what's causing those? We'll investigate that next class. So have I covered things? It's a challenge when flipping away from your slides to doing Excel. So we did that. We looked at that. We found that negative correlation with income and the residual. And then once we got it in there, looking at the correlation between residuals and the variables that were left, here was the one with age, the minus 0.09. So maybe we could include it. In the slides, I didn't. So a strategy for improving our model is to put more variables in. And we should be adding variables that add new information. So it's incremental. It's stuff you didn't know before. So that's why limit, no good. But income, yes. Age, a little bit. That a common problem, though, is this multi-linearity. Our variables are interrelated. So it makes it messy in doing this. It doesn't necessarily hurt the quality of our model for predictions, but it does from the perspective of trying to explain why you get the results you got. I recommend that you add variables the way you see, is it going to give me new information, is by looking at your mistakes and find the one that gives you the most new information. So it has the largest correlation with your mistakes. And we go through this over and over again in an incremental fashion. Here. That what else can we learn? We can learn from the pictures. I may not be able to get any more out of that correlation table, tell me what to do, but the pictures are telling me something. Pictures are telling me that there is something strange, that sprinkling. And that may be because there's a nominal variable. Maybe they represent a specific group of customers. Can I find what group it is that is causing me grief? And it may be a specific group because remember, we've got students and male and females and other variables there. Or it may be within a certain number group. The that So there are a bunch of things in that regard, but the other is you probably saw with the ratings. I don't know if I've still got it here. Show you the new residuals? No, not there. It's not in the slides, but we saw it. It looked like it went down and up. It looks curved. So ignoring the stuff in the sky, there's something going on here. So what's that? And maybe it's not a straight line. Maybe I've got a curve. So how do we deal with curves? But those, again, we see through the pictures. Anyway, I'm out of time and my phones keep ringing, so I've got to leave you. Take care, and remember, test on Friday, quiz on Saturday, and I hope the test is not as bad an experience as the last one was. You guys have a good day. Take care.